So I had evaluating a composite inverse trigonometric function. So I chose the problem, the angle cosine times the angle the inverse tangent with 5/12. So this was just what I had written down for my notes explaining how to do it. And I'll just show you on the calculator for the formula once we get down here for the actual solving part. So I wrote it out step by step. So step 1, you let the angle represent from this angle pair. So you base it off of that. So 5/12 is positive, so it would be in quadrant 1. After that, you have to remember that tangent is opposite over adjacent, which would be y/x. And so we would do y/x. So in this case, this would be y and this would be x. And then we have those numbers already. We have 5/12, so we have to find r, the hypotenuse. So the formula used for that is r equals x squared plus y squared square rooted, or the square root of x squared plus y squared. So x is 12 and y is 5, so you square both those. 144 plus 25, square root of 169 is 13. So after that, you have to remember that we are solving for the cosine. We did use this formula for tangent for the first two, but for cosine, it's adjacent over hypotenuse. So now that we have hypotenuse, we can put x, which is 12, over r, which is 13, and that gives us our final answer, which is 12/13. That's the exact value of cosine, the inverse of tangent, times 5/12. So these were my notes on that. This was what I learned from the textbook and my math lab. So I tried to organize it in the best way. I did step 1, step 2, step 3 for explaining how to solve the whole thing. So yeah, that was my evaluating a composite inverse trigonometric function.